Hi, I'm Alex,
And I'm Mike.
and today we're looking at the physics in basketball. And Mike has 4.2 seconds to run down the full length of the court and make a basket before time expires.
One.
So here's the problem we want to solve. How far away from the hoop is Mike when he shoots the ball, and what velocity must he shoot the ball in order to make the shot? In order to solve this problem, we need to split it into two parts. The first part is a linear kinematics problem. In order to figure out Mike's distance from the hoop, we must first find out how far he traveled. Before we start the problem, we must first list our given values. Mike's average acceleration was 3 meters per second squared, and he accelerated for 2 seconds. We also know the change in time is 3.7 seconds because Mike shoots with 0.3 seconds left on the clock that started at 4 seconds. Lastly, we know Mike's initial position is 0 meters because he starts at the baseline. With this information, we can find his final position. Here's a look at Mike's motion again. To figure out the total distance traveled, we had to find Mike's displacement while he was accelerating, and add it to his displacement when he had constant velocity. For his accelerated motion, we used one of our kinematics equations to calculate his displacement to be 6 meters. For the time while he has constant velocity, we use the same equation as before, but set his acceleration equal to 0, his initial position to 6 meters, and his change in time to 1.7 seconds. We found that his total displacement was 16.2 meters. So Mike's distance from the hoop equals the length of the court, 28.65 meters, minus his displacement, 16.2 meters, which is 12.45 meters.
Part 2 is a projectile motion problem. We need to find out what angle and magnitude the velocity Mike needs to shoot the ball at to make the shot. Before we start this problem, we need to list the givens that we will be using. First, we calculated x initial, 16.2 meters in part 1. X final we found was the length of a regulation basketball court. Y initial is the height from where the ball was shot. Y final, 10 feet, is the height of a regulation basketball hoop. Acceleration in the y direction is due to gravity, and the change in time is 1.1 seconds, which we measured from the video. 3 of our givens were in feet, so we need to convert them to meters by using the conversion factor that 1 meter equals 39.37 inches. After our calculations, we found that x final equals 28.65 meters, y initial equals 1.83 meters, and y final equals 3.05 meters. We used our kinematics equation, plugged in our givens, and found initial velocity in the x direction to be 11.3 meters per second. To find initial velocity in the y direction, we used the same equation but plugged in our y values. We calculated the initial velocity to be 6.5 meters per second. Using trigonometry and our initial velocities, we can find angle theta. In order to do this, we take the inverse tangent of our initial velocity in our y direction over our initial velocity in the x direction. Upon doing this, we found the angle to be 29.9 degrees. One of the many ways to calculate initial velocity is to take initial velocity of the x direction and multiply it by cosine of theta. Using this equation, we calculated our initial velocity to be 9.8 meters per second. So if Mike shoots the ball at 29.9 degrees with a velocity of 9.8 meters per second from 12.5 meters, he will win the game for his team. So did he?